Okay, so I saw Tyler's question before I got up for the break, and it was a good question, which was, how is all this going to interact with, libraries, precompiled stuff that you're going to link to? And originally, I thought that was going to be a problem too, but I'll tell you what the plan is. This is not set in stone, but this is a current plan, right? I had assumed that you would have the same kind of problems as you do in C++ or whatever. But I was talking to a friend of mine, who some of you will know who this is, but he runs a game company that makes libraries that people buy commercially for sometimes a great deal of money, right, for video games and related subjects. And I assumed that for people in his kind of business that you needed binary libraries, and so you'd inherit all these problems. But what he said was no, he would actually prefer having the language be powerful, and that if you have compile time metaprogramming like we have, then if you needed to obfuscate some things in your library that were like trade secret, or you just need to prevent somebody from easily cloning it, right? Then you can do all sorts of code scrambling and changing the names of things and whatever, right? So the thought is that actually there won't be platform-specific binary libraries. There would be one set of libraries that come in a binary format, but it's basically a parsed syntax tree that has not yet gone through all these other stages of compilation. So all the features we showed today would work just fine with that, as long as other metaprogramming things that are yet to be shown. And I like that a lot. And the thing is that actually simplifies the lives of everybody, basically, because if you're shipping libraries, right, like you make an audio library or something and you're trying to ship that for 8 platforms, you only have to ship one thing to the people trying to use your library, which is pretty damn awesome, right? You don't have to recompile it for 12 different ways because 2 or 3 of your platforms have like 32-bit and 64-bit versions and exceptions turned on or off or whatever the hell, right? So that's actually a great boon because you have a massive support decrease if you're authoring those libraries. And on the developer side, like how many times have you spent hours on some stupid build problem because like some binary library is like not quite right and you don't know what's going on, and the build settings when it was built were not quite the right thing in some subtle way compared to what you're trying to do now, etc., right? So you get rid of all that stuff if it's kind of precompiled but not really, right? So then you go through all these other stages of compilation. That's the current plan. We'll see if that plan survives contact with reality, but I actually like it quite a lot. Now, you obviously have to compile the binary at some point, and if you're incrementally compiling locally, then you probably do compile. You probably don't compile one separate .o for every source file or something, because that's kind of stupid. It's not the right trade-off for modern computers in terms of how long it takes to incrementally recompile versus and relink versus whatever. But you probably pick units that are subunits of your program to incrementally recompile, and so you're probably compiling to binary there and linking there, but that's just local to your own machine, right? And it doesn't pollute anything else. It doesn't pollute distributing your library, compiling with it, or anything. So I think that's pretty good. Maybe there'll be pushback on that, but I honestly, when I think about the number of problems that solves, I'm very excited again as a programmer, because I'm like, yes, things will get simpler. There's this, like, anytime I can locate an assumption that is making our lives painful, that's really an assumption that can be changed, then it makes me very happy. And I think that compilation model is an assumption that can be changed and should be changed because it's actually very painful for us right now. Other questions? Someone's saying it would be nice to not have to put satisfy interface by hand. I think the requirement on the polymorph types could be inferred by the IDE. That's possible. Like you could have an IDE that does this for you. I think it'll be a lot easier with this language than many to have your IDE tell you that stuff because the compiler is going to be very good at returning information back. We'll do that later. Also, if you wanted to do satisfy interface, I don't know. I feel like you might always want to do that for reasons that the IDE or compiler don't understand. So I think the technique to do it should always be there. But we'll see. I mean, part of the reason, so the thing about all these features that I showed today is a lot of them work very differently than how other languages do things. And so it's actually kind of hard to tell. Like I always say, I've been programming in C++ for 20 years. I've been programming in this language for 0 years, right? So I don't actually know what it's going to feel like to program with these features in the long term, and I don't know what I'm going to want to do. And so I want to just kind of let things roll a little bit and see when I start writing real software with these features, which of them are really truly the most useful, which ones I want to change the behavior of to be more useful, etc. So anything you see in these demos, again, is preliminary and will be changed into whatever is maximally effective for software development, generally for the kinds of software that we care about. Someone else's question follows after 2 lines of code. Add 2 components to it's hard to read in the narrow Twitch chat window. The question is, should there be a way to pass X component to add 2 components? Pass X component. I don't understand the question, I don't think. Oh, you mean okay, so for F, yeah, I don't see why that wouldn't just work. He's asking if you can, pass a function that selects the X component, right, to another thing. Oh, I see. Right. The point is that the arguments are different types, right? So he's passing a function that takes a specific type variable, and he's applying it to 2 different types at the same time. Right now, that would work. Wait. Okay, so here's the thing. The thing that I don't do generally right now, all the examples of polymorphic type variables getting resolved, they either happened by you manually baking or you calling the function. You could imagine resolving those types via type match, like when I pass a polymorphic function to something else. So if you remember, like that when I was doing map and square, right? This version of square takes integers and returns integers, right? I could have made one that takes $t, right, and then works on anything where this works. The thing is that when I pass that to map, it won't know what the hell to do, right? In reality, you maybe should be able to do that, and then it would do a match, and it would say, okay, well, t is still a variable, so this function is still polymorphic, and then we apply this body with this argument polymorphic still. And if that capability is added, then the answer to your question will be yes, that would work. Right now, we don't do that. So, and the reason we don't do it is just, like I said, I don't know how it feels to program with this stuff, so I don't know if that's something I really want to do or if it's just a needless complication that's going to be heinous or whatever. I feel like we're going to at least want to be able to pass that to concrete types, so I feel like you at least want to be able to have a function like this that takes a type t and then pass that to something that wants an int. Like, I feel like that's something you want to do, and I just haven't done it yet. It says you can straightforwardly imagine how that works from what I demoed today, right? And then whether you can still propagate something remaining a variable, maybe you naturally want to do that, or maybe if we do that, it generates, you only usually do it by mistake, and then it generates really confusing error messages and nobody likes it, right? I don't know. We'll see. But yeah, that example as you posted would not exactly work right now, but it's possible that it would. Can I think of a way to make a generic cross-copy function that can copy from any struct type to another by matching member names? Yes, that's kind of trivial. You can do that based on what I showed already. You know, I mean, provided either the fields are the same type and just in different places, or if your cross-copy knows how to convert between different types, which any copy function needs to have an opinion about that, right? Otherwise, what are you doing? So you could write that right now. It's fine. Can polymorphic variables capture pointiness? So $t is equal to vector3. So pointer to t would be pointer vector3. Yes. Exactly what Dr. Jeet said is correct. The t is just pattern matching for whatever in the type expression would be in there. So it can be arbitrarily complicated. It can have things on the outside, right? Yeah. Sorry, someone's saying I should have done another demo sooner. Maybe that's true, but I wanted to get to the exciting part. If I had just demoed the basic polymorphism for functions and not demoed the cool features, that would have been a little bit of a drag because I wanted to show the cool features and I wanted to plow through everything to get there. So it's fine. This will go on YouTube. People can skip through it. Maybe there's a way. There's got to be some site that lets you watch YouTube videos at like 1.5 speed or something. It seems to me that it would be possible to use all those compiler directives and create a completely different language that will compile. You might be able to do that. I think if you really want to support a higher level language over this language, you probably don't do it exactly with these directives. You probably just parse something new. But this language works very hard to provide all kinds of metadata that you can use, like these type info things, which makes interfacing with a higher level language, whether it's a scripting language or another compiled language or whatever, a lot easier than it would be from C++, for example. It's still a nightmare in C++ to interface with anything. I don't know, C++ committee keeps making weird decisions about what features to implement and ignores giant gaping holes in the language, as far as I'm concerned. Will this language be functional? I assume this person means no. This is an imperative language. It is a precompiled imperative language. You can think of it as being like a super powerful C class language, but that's also much safer than C, much simpler and cleaner than C++, and faster than either of those languages. That's what we're aiming for. We're not totally done, by the way, but we're getting there. We're already, by this point, we're way more powerful than C. We're possibly more powerful than C++ almost, except, like I said, I only demoed polymorphism of functions. By the time we get to polymorphism on data structures, we'll be more powerful than C++. And then, and also cleaner at that point, right? So that's what we're aiming for, and we're succeeding, which is great because when I started this, I didn't know how successful this effort would be, but it's been tremendously successful so far as I'm concerned. Someone's asking, do I find myself disappointed at times by having to add features which add more overhead or baggage than I would have wanted? That's how I felt when making my first compiler. It always starts so elegant. Sort of, but I have learned to enjoy complexity. Like, it's something that I get out of game design. when it's the right amount of complexity, it's actually very enjoyable, right? The thing that sucks is when you get bogged down and your newly complex thing makes your old things less good or whatever. And I'm trying to avoid that. And there's an art of design that's about adding new things and caressing the shapes of the old things until they fit together properly and don't make anything more complex than you need, right? So, for example, if you don't like to think about metaprogramming or generics, you can ignore all this generic stuff that I showed today, and you still have a perfectly useful language. And in fact, you may be using generic functions sometimes and not even know and not even care, right? So for example, in the basic library, like I said, array add and unordered remove and reserve are all generic functions, and you may just call them and you don't know and you don't care because it just looks like any other function call. And that's great. Like when you have that simplicity, you're good, right? We don't take a hit in strength of error messages. We don't take a hit in compilation time, really. I mean, we could measure that eventually, but so far we still compile faster than you can tell. So yeah, we'll see how that goes with bigger programs, but we're always implementing things with an eye toward making them optimizable. We're never building a design that's going to balloon in an unmanageable way. So I'm actually very happy with how this goes. I had assumed that by the time I did generics, things would just be kind of unmanageable, but they're not. They're actually, both in a design sense and a technical sense, things are manageable, right? So if I do a line count, if you strip, blank lines and comments, we're at 18,000 lines in the compiler. It's more powerful than C, approaching the power of C++, and it's 18,000 frickin' lines. Like, compare that to the line counts of some other compilers that you've heard of. Now that said, right now we're running without a backend, and we're going to be piggybacking on LLVM probably to do a backend for a while. But compare that to the front and middle of other compilers. It's pretty damn small and nice size. So I'm very happy with that. If I had guessed how big the compiler might be by the time we got to this point, I might have guessed substantially bigger than this, and it's not. So that's cool. When do I think I'll actually use this language for writing software? Pretty soon. I might do some toy stuff with it soon. We still have the Galaga program. That's kind of software, right? So if you don't remember this, I broke it. Oh, right, because I was adding text rendering and I'm not done. Let me just take that out. So this is sort of software. This is the most intricate software that's ever been written in this language, and I demoed most of this on the first day. So this is still the state of the art. I was about to add text rendering so that you can see a score and stuff. And that, I have about 2,000 lines of C++ of text rendering stuff that I'm porting over. So that's my first serious porting. And then once that's done, then maybe it's time to branch out and do other things. But also, I want polymorphic data structures before I start writing real software, and then we'll just see. What do I think about concurrency? Will it be implemented? Yes, you absolutely need concurrency. Yes, there's a lot of ideas for how to do concurrency better than in C++ or to support it for real programs. We'll get into that some other time. It's a totally different subject. Have I considered having explicit loop unrolling? Yes, I've considered it. It's just, it seems like a relatively easy feature or a feature that's been done in some other languages like shader languages. So you can visualize exactly how loop unrolling would work if it were to be supported. So it doesn't seem that important for me to do it now, because I didn't see these consequences of I didn't see value baking, for example, until after I was doing polymorphism. Then I was like, oh, I could bake values. That would be so cool. So I'm aiming right now on unknowns, and then we can fill in those kind of knowns later. Another thing you could do, right, is you could flatten your branches in cases where that's possible, right? Like you can do in HLSL. So that may happen. We'll see. But it's relatively easy, so we're not doing it yet. Someone's asking if I was going to rewrite Braid or the witness in this language, how many lines do I think it would be? I don't know. It'd be shorter because you wouldn't have header files at all. So first, delete all your header files. Type inference makes the code shorter. Doesn't necessarily reduce the number of lines by that much, but it makes each line shorter. And I don't know. Like I feel like with the generics that I have here, I feel like I could use them to build more powerful things that are more understandable than the equivalent things in C++. So especially once you have modify procs to like mess with things. So I feel like I could use them more generally, right, in order to handle more things and have a smaller code base. But I don't actually know. That's speculation, and you would have to see how it turns out. Have I tried an alternate implementation of virtual dispatch? No. What you have seen in today's demo is everything that I've ever done with polymorphs in this language. So it was literally like exploring all the low-hanging fruit, building a demo out of what I did, and that's what you saw. So I think more dispatchy things will come later, maybe. I don't know. Am I thinking of any way to inspect the polymorph interface of a function? Yes, I probably want to have a way to do that. The outer style of metaprogramming, like as you have your build proc that controls what the compiler does and stuff, which is going to get a lot more sophisticated and interesting eventually, will be able to do that for sure, because after the program's compiled, you can look and see. The question is just, while your program's in the middle, what do you do? Because some people might have called that function, and other people haven't been compiled yet that call that function. So you might inspect it in the middle, like while all the polymorphs are not generated. So you would either, maybe that thing just has a dependency that says this has to run absolutely last, and then you get the final notion of what is there. Or what? But then once you start having multiple things that have to run absolutely last, you could deadlock on each other, right? Or something. I don't know. Speculative. So I do think it's very important, though, like I've said repeatedly, to have a very clear idea of what your compiled program is, rather than squishily relying on, oh, maybe it'll inline, or oh, maybe it'll, AVX. Or SSE my code or something. You want to know exactly for sure what the compiler is doing. So anything we can do to support that will be supported. Very important. Am I planning on operator overloading? I think so. I think you kind of need it. You at least definitely need function overloading. That's something that we haven't have yet. And operator overloading, I think we will have. Now, C++ gives operator overloading a bad rap because the first examples of operator overloading in C++ were so amazingly stupid that I couldn't, like the IO stream operators and stuff, whose idea was that? I'm sorry if you're watching this, but it's the worst idea ever. As soon as I saw the overloaded double less than and double greater than in C++ many, many years ago, I was like, these people have no ideas. They just... Yeah. Now, however, if you're building games and you're doing mathy kind of stuff, it is very useful to extend the definition of stuff like plus to vectors, right? And times for vector times scalar and whatever. When it has a system behind it and it's very rational, it's very helpful. I actually used to refuse to do any operator overloading, and I would always say add open paren v1, v2, and whatever. And that's fine, you can do that, but at some point I switched to operator overloading, and I find that disciplined use of operator overloading is actually very helpful. Now, as I said in the first couple talks, the philosophy of this language is to help good programmers be good and not prevent bad programmers from being bad. So bad programmers are going to do lots of crappy operator overloading, and it's whatever. They're just shooting themselves in the foot. Maybe the IDE can highlight the operators in red or something so that you know they're overloaded, so you can at least read the code. That kind of thing didn't happen very often in the early days of C++, but in this language especially, the compiler is going to talk to the IDE, right? And it's going to tell the IDE how an operator was interpreted, right? So there will be no ambiguity about what it was. So, there are things that maybe make that better as well. But yes, my inclination is that operator overloading will happen, but we'll see. Someone's asking, what is the scope of the code generated in body text? It is whatever the scope of the function is that the body text was attached to. Let me, because you can nest functions anywhere in this language, right? That already works great. So here, what happens is to process the body text, we build the header for this length function. There's like an invisible header that lives somewhere, and it gets nested in this scope with an empty body. And then the body text comes along later and supplies that body and basically wedges it into that scope. So that's within the scope of this body text function, which is within global scope. So if I had defined some constant up here, in fact, let's do that daringly. Let's see if this works. I'm going to define label in all caps, right? It's a constant that is cowabunga. Oh God, I'm having a bad feeling that this might not work. But I'm going to say, oh wait, how do I use that? I can't because I'm returning a float. Okay, my body of my function is going to say printf %s new line, and I've got a, I hope backslashing of quotes still works because I haven't tested that a long time. Label. And then return that. So maybe this will work. So we don't support closures yet, so you can't capture values, but the reason I think this may work is because this is a constant, so it can get directly substituted in here and you don't need a closure. It may not work if the compiler doesn't substitute it the way I think. Let's find out, shall we? Let me go down to make sure this is getting called. Oh, this is exciting. I don't know what's going to happen. Let's clear the screen. Drum roll. Oh, it didn't work. And it crashed. Oh, maybe a new line in string constant. Oh, because I didn't backslash my \n. So the compiler shouldn't have crashed, but I did make a mistake. So backslash n. Hopefully that works. Yeah, it didn't. What happened? No, you know what I can do? Here, let's make it simple. Let's say printf label, just so that there's no ambiguity about that. New line, which is a function in global scope that I should be able to call. All right, maybe this will work. It worked, except new line didn't happen and the lengths got messed up for some reason. I don't know. Let me see what the body text is. Now I'm interested. Printf label, new line. So why? Something about what I'm doing messed up. This is a compiler bug, basically. It's what you get for the first demo of all this stuff. But this is good because now I have something to debug. Like, why is it also not calling new line? That's weird. Like, why is the new line not happening? Anyway, let me put a new line in the label so I'll at least feel more successful. New line in the label. Should have done that in the first place. So now we at least get the new line. But yeah, for some reason, this stuff is not working. So something about the way that I'm wedging the stuff into this scope is maybe only working for the first statement in the block or something. It's a weird bug. It'll get fixed. Thank you for helping me find a bug. But yes, the answer is it's in whatever scope as demonstrated by this. What happens if I move this to the outer scope? It's still broken. So it's actually, in fact, it's just something about having multiple things. Like if I just do new line, does that? Wow, okay. Yeah, okay, that's broken. So if you just, for some reason, have multiple statements, it's broken. That's an embarrassing bug, but it shall be fixed. Can you only bake values with basic types, or can you also do structs array? You can bake anything, right? You know, anything that'll fit that type spec that you declared in the function header, right? So yes, I can bake something as operating on a struct or anything. Function. I can bake a function argument into the other function. At what point do I think this language will be ready for other people to start using it? I don't know. In calendar time, maybe 5 months. I would say we're maybe halfway. Like I started 6 months, 7 months ago. So maybe another 5 or 6 months till early adopters could start hacking around with it and playing around. For widespread use, it'll be longer than that. You know, production use, it'll certainly be a little while, but in 5 or like this year, I want to put the source up and just let people start playing with it and see what they do. But before we get to there, there's some substantial features that still have to be added. And as you saw from that last thing, there's a little bit of robustness testing that needs to happen. Like, hey, that feature that I demoed didn't work as soon as I started hammering on it harder. So why is that? So we just need to debug that kind of thing. What happens if I put the new line? If I put the new line second, we're going to return, and we won't do the new line. But I wonder if it's broken still. No, that works. So like I don't know why calling new line is affecting the scope somehow. I bet it's a really stupid bug that's like one line of code in the compiler. Sorry. Okay. Could I explain why I chose this syntax? It looks a little clumsy. It is a little bit clumsy in the sense of there's a lot of colons all over the place and stuff compared to C. That's not too bad once you get used to it, but the reason there's colons all over the place is just so that I don't have to think about parsing. When the compiler sees a colon, it's very easy for the compiler to know what's going on. So I can develop the semantics of the language without actually worrying about the syntax. Once the functionality of the language is done in terms of all these cool features, then we're going to go back and question everything about the syntax. There's already a couple things that we already know is going to change, like using the caret for pointers is going to change because that's inconvenient for keyboards in certain parts of the world, etc. So don't worry too much about the syntax. It'll change, right? What we are demoing in all these demos is the actual power of the semantics of the language, right? What you're seeing now is sort of the worst case for the syntax, and it'll get better toward the end. Someone's saying, any plans for UFCS, universal function call syntax? Maybe, but I'm not convinced that you'll call functions in dot form anyway, because that's kind of redundant and silly, actually. I mean, there's some little benefits to it, but they're cosmetic, and in return, you get a lot of drawbacks. So why not just dismiss with that whole member function thing and just not have it? Lots of functions, lots of languages don't have member functions, so why don't we do it? I think I'm going to start programming without member functions when I write real software. So for example, in my font rendering that I'm importing right now, the C++ version of that has a font class with members, and I'm just doing it fully UFCS style where there's no member functions, right? You just pass the font as the first argument, and it's probably good to do that. We'll see, right? The idea is by getting rid of that useless piece of language complexity, you can substitute in something else that is more powerful, or maybe you just have a simpler language in the end, right? So I'm not convinced that you need .style function calls at all. Obviously, I've demoed in earlier demos, if you have an actual function pointer on a struct, you can call that with dot whatever. But in that kind of like virtual table member function thing, I am not convinced that that's necessary. Would I reduce runtime on polymorphics by using check call? No, because check call, basically the modify procs that we had today are like a version of check call that runs before the function gets generated or while it's getting generated. So it's basically the same cost as a check function. There are some things that you may be able to do at lower cost in terms of whole program metaprogramming. That'll happen later. Somebody else can give a hint to the visitor about how do you program for games? Speaking of talking to the IDE, would it be possible to stop mid-compile and have an IDE debugger inspect the current state of the compilation process? I have a surprise for you that's along those lines, but even better. I'm going to do something that blows the hell even out of that suggestion that you just had. It's one of my surprise features for later. Not too much later, but maybe 2 or 3 demos from now. We will demo a feature that is so much more powerful than that. But you're thinking in the right direction, yes. Am I going to develop the first IDE in-house or provide tools? Well, I think what I'm going to do is write my own text editor to replace Emacs, and that'll kind of be my IDE. And it'll have, it'll use this language instead of Emacs Lisp as the extension language. I'd already much, much rather program in this than frickin' Emacs Lisp. And then the nice thing about that is you can run it interpreted while you're goofing around in the editor, but then you can compile it into compiled code and then just load it in the editor as a DLL, and then it's super fast, right? So you wouldn't have all the slowness problems that Emacs has. But then, people could use that then to build into more of an IDE if they want other things, like add the debugger and stuff. But my priority in the nearer future is just an editor. Would I consider extending body text to do a PHP style so you can write most of the code normally, then a few lines of generated code? Yes. Like I said, I don't think that that's that hard. I talked about, I guess I deleted it, but if you saw that whole body text section, I talked about a version where you can insert something that's pre-parsed, where you don't have to generate a string at all. And that's nice because then you get parse checking in the middle. But you could also do a version that opens a scope in the middle of your function and just compiles a string into that scope. Like that would be the same as what body text does, but instead of replacing the whole body, it replaces something in the middle. That would be a straightforward extension of what I've done. As you saw, though, there's at least one bug that needs to get worked out in body text before we start doing that. But yeah, I mean, that's what I think is like, as one of the things I said when I covered body text is it's kind of a big gun that's a little bit inconvenient to use, right? Because you've got to generate text for a whole function. If you just want the function to switch out what it does in a couple of places and write most of it normally, that would be a subset of this functionality that would be easier to use, that's not hard to implement based on what you've seen today. And I think that that's probably important to have. And we'll do it at some point soon. But I think before doing that kind of thing, I want to go and do the other major parts of polymorphism, like the polymorphic types and whatever, right? And then when I start writing real software, if I start going bananas from not having this in-between feature, then I'll do it. Because I don't think it would take more than a couple hours even to implement, because it's seriously just a small modification on body text. A couple hours. It might literally only take half an hour, 20 minutes. I don't know. Sometimes things go really fast that way. When will we have an ineffectual committee? Blah, blah, blah. No joke questions, Tyler. That is guaranteed. If the language is successful and people adopt it, it is almost guaranteed that you'll have an ineffectual committee, right? You can try to stave that off for a while by trying to have some knights of the round table who guard the thing and who are experts and whatever. But at some point, it's just like if you build a company, once that company goes beyond a certain size, if it lives long enough, it's going to become a lame, large company. That's just what happens. But you can try to extend the goodness of that lifetime, and you can try to make sure. So, C++ started becoming a really lame language immediately. Sorry, anyone involved in it, but that's how I think. It has some good features, but a lot of its features are misguided, right? But the strength of C++, or one of its strengths, is it's built on C, which is still a core language that's pretty good. K and RC was not very good, actually, in many ways. It was good enough, I guess, for the time, but like ANSI C started getting pretty good, and it's got that as its core, right? So you can always fall back to that, and that's what I do. I don't use that many C++ features. I use certain ones. I use single inheritance and very simple templates in very limited cases, right? But you can always fall back on that core of C. So what I'm trying to do right now, there's a little bit of like a foundation series kind of thing going on, where I try to build a core that'll last a long time, right? And whatever gets agglomerated on top of it, like if Electronic Arts starts using this language and they have their in-house version of it, and they add some stuff that's kind of useful but kind of ugly and you don't really want all of it, the core is still strong and you can still just use the core, right? That's what I'm aiming for. We'll see how successful that is. Maybe this will become a lame committee language next year and there'll be nothing you can do. I don't know. I don't know. Some things are forces of the universe and we can't do anything about them. Certainly, once the basics of this language are done, if you want it to be a serious production language, a lot of support things need to get written for it, right? Like a frickin' debugger, hello. And that requires people working on the thing, people being more than me, right? So once we hit that point, we start, anytime you work on something, your opinion of what that thing should be makes it into what you do. So you start having broadening opinions of what things should be, and that's the start of committees right there. So we have to be careful. QTE. Am I working this alone? Yes, I'm doing this alone right now. When I say we, it's the royal we, or the we in anticipation of other people working on the thing eventually. I already want to bring one or two friends in relatively soon, once the polymorphic structs are in, to help make sure that they work in various interesting cases. And then we'll see, But right now, it's only me having implemented everything that you see. Yeah, I guarantee you that I've done some things in this language that Casey doesn't like. But that's fine. Not everybody likes everything. That looks like we're at the end of questions, and I've been talking forever. If we have more questions, we can cover them next time. Thank you for coming. It's going to be a little longer than usual for this to show up on YouTube because it's a long video and I'm going to need to edit it tomorrow to cut out that goofiness at the beginning with the, with is the volume level right? Are we there yet? Etc. Can you hear me now? So, but it'll make it on YouTube hopefully by the end of tomorrow. In the meantime, or after that, if you would like to email me at this address, if I could type, to talk about anything you want to talk about relative to this language, you can do so. This is not a mailing list. This goes directly to me, and it's just for talking about features here, questions, ideas that you have. Please, no syntax emails, please. No syntax emails because we don't like those. But any other things about language semantics or how to build software, whatever is welcome at this email address. And yeah, I hope you enjoyed what we showed today. I will try to make the next demo, which will be polymorphism in data structures, as powerful or more powerful. I have a feeling it'll be a lot along the lines of what we have now, but there's some other features about constraining code bloat that people don't usually care enough about that I would like to attack. So there you have it. Thank you for your time and attention. Those of you who have been here for the full 3 hours, I very much appreciate it. I'll see you next time.